Hello everyone. तो आपकी रिक्वेस्ट पे you have request me to make the video, so I'm here. The first topic we'll be discussing is detect loop or cycle in a linked list. So the problem statement is like you will be given a linked list of this format, and it will be like the first node points to second, second node points to third, and the third node points back to another node in the previous section. So it forms a cycle over here, as you can see. Similarly, the second input case would be the first points to second, second points to third, third points to fourth, and this fourth does not point to any other node, that is, it can point to a null node. So it is a linear linked list and with no cycle. So we are asked to find if a linked list is of this format. Okay. So if the linked list of this format, our helper function will return true, and if it's of this format, it will return false. Okay. Coming to the code now. So the algorithm that we'll be using is called Floyd cycle detection. So while using this, we can get a big O of n time complexity, okay, and a space complexity of big O of 1, okay. So we'll be dealing with it. So whenever you are asked to do a linked list question, so in case of array list, like you can put the import java.util.asterisk over here, and how you use the array list, you could write array list, then you write the data type, non-primitive data type, integer, then you can say list equal to new array list, and you can do like this. Now you can also do the same thing for linked list as well, but no companies or no exam would prefer these scenarios. So what you have to do, you have to create the linked list from scratch. Okay, so for better understanding, I'll limit util package to get only scanner or inputs. Now we only have scanner, we cannot use the collection framework at all. Now what we have to do, we'll create an inner class. Okay, inner class. So static class node. Now, what is the concept of inner class? That's coming back from OOPS concept. Okay, so you can revise that, or I'll let you know whenever it's required. Okay. So what we'll do over here. So whenever a node is there, okay. So a node looks like a box type of figure, is something like this, and it can store 4 inside the box. Now, what the node has, it can have a data. Okay, it can have a data, and it will have a next pointer pointing to its another. Okay. So that is the features of a node. So we'll have two datas over here. One will be node next, the pointer, and one will be int data. Okay, integer type of data. Now we can create a constructor over here. Okay, as you know, constructor don't have a return type, and we can pass in a data over here. Okay, and we can initialize the values. So we'll say this dot data, that is the non-parameter, equal to data. So in case of the name is same of the parameter data, parameterized variable, and the class variables. So we have to use this TP. Okay, and now we will say next, this dot next equal to null. Okay, so this is how we'll create, and it begins over here and it ends over here. Okay, so now this is a function called has cycle, and it will return true if the linked list has a cycle, and false if it does not have a cycle. So what we'll be following is called noise algorithm. Okay, to detect cycles in linked list. Okay, so over here we'll be talking about linear linked list. Okay, single linear linked list, singly linear, not double linear linked list. And in double linked list also, this approach will also work over there as well. Just the thing is in double linked list, a previous pointer is there pointing to the left previous node of the current node. But this algorithm works in forward manner, and so it will apply to both singly linked list and doubly linked list. Now what we'll do, we use the concept of slow and fast pointers. Okay, so let's see how it works through some animation. So we'll open up an article. They have made a very good animation on it. So initially, our slow and fast pointer will point to the head node. Okay. Now what the slow does, it moves one step at a time, and the fast move two steps at a time. Okay. So initially slow and fast will be on head. What will happen next? Next, slow will move from here to here one step, and fast will move two jumps. Okay. Next. Now slow comes over here, and fast was over here only. Now it moves two jumps. Okay. See next. Now slow came from here to here, and fast make up to here. And now slow is over here, fast is over here. Okay. And after some movements, there will be a scenario where slow and fast will point to same node, same address. And this is the condition that will verify that linked list has a cycle. हमारी लिंक लिस्ट के पास cycle है, loop है. Okay. So अब we'll use the same concept of slow and fast and we'll convert it into the code. It's very simple. कैसे करेंगे? So we'll do it like first we'll initialize node slow is equal to head. Okay. And node fast is equal to head. Okay, simple. Now, what's the condition? We have to go back. So, coming to our linked list with no cycle. So, when there's no cycle, that is the cycle can't be detected, and the condition slow equal to fast will never appear. So, what will happen? Initially, slow and fast will point over here. Next, slow will come here, and fast will move two jumps. So, one time and two times. Okay. In this next iteration, slow will come from here to here, and fast will move two times, and it will jump out. So now fast will point to null. Okay, so I think you got the break case, the while condition. So what we'll do, while fast not equal to null. Okay, and maybe a scenario of like odd number of data or even number of data. So it could be fast dot next not equal to null. Then what we'll do, we'll say slow equal to slow dot next, that is moves one step at a time. Then fast is equal to fast dot dot next, that is moves two steps at a time. Okay, good to go. Now what we have to check the condition. If at any instance slow is equal to fast, that means slow and fast are pointing to the same node. Then we will do return true. And if it's a linear linked list with no cycle, then at the end fast will point to null, fast dot next will point to null. Okay, one of the conditions will be satisfied. So the while condition will go move to false statement, it will jump out, and then we will return false. Okay, so this is the small code snippet. The function has cycle, which is using the Floyd's algorithm to detect the cycles in a linked list, be it singly or doubly. And this is the inner class that is giving us an opportunity to use this keyword node and have the features of data and next. Okay, good to go. Now coming to the main method. So there can be a scenario you are asked only to complete this function only. Maybe this is already built So this could be given in this form for your reference that the node class is made and it has these features. Sometimes data is also given as D or something like value, VAL, okay. But in our reference, if we have to write everything in the program, like from scratch, everything from start to end, so we have to, तो हमें मेन मेथड को पूरा लिखना पड़ेगा. मतलब we'll have to use the scanner class, create an object of scanner class, ask the user how many nodes have to be made, the size, then we have to create a for loop, then iterate from the for loop until the size is reached. Okay, then each time we'll ask the user what is the data, we'll create a new node, we'll put the data, and then we'll point it to the next node at the second time, and so forth and so. ठीक, ऐसे चलते हुए लास्ट में नल को पॉइंट कर देंगे एंड हमारी लीनियर लिंक्ड बन जाएगी. ठीक है. नेक्स्ट हम क्या करेंगे, व्हाट विल डू नेक्स्ट, विल आस्क द यूजर सम पोजीशन एंड नेक्स्ट अब हम उस पोजीशन पे व्हाट विल डू एट दैट पोजीशन विल कनेक्ट अ साइकिल एंड विल क्रिएट अ लूप एंड देन विल कॉल आवर हैश साइकिल फंक्शन टू वेरीफाई. तो मेन मेथड में क्या करते हैं हम, what we are doing basically is we are creating a linked list with cycle and calling the function has cycles such that it produces a true output. There can be a scenario that we have an input without a cycle, so it will trigger false. Okay, so let's see the main method line by line. Over here, we are creating object of scanner class to take user inputs. Okay, now we are taking asking user how many nodes are present in the linked list. Supposing the user enters some negative value or zero value, that means there is no node at all. The linked list is empty. The linked list is null. So we simply print anything. So in this scenario, we can print 0 or we can say empty linked list. Okay. And then we can also put a return statement over here to jump out of the main method. Now, in case size is positive and has some value, so what the size can be? Size can be equal to 1, 2, or say 5, anything. Okay. Now supposingly, we suppose size equal to 5 is given by the user. So what will happen? We have to fill the values and create the nodes, and then we have to create the linkage. That is the next of each node. Okay, make the connections. Now we'll use two pointer, head and tail. Head will point to the first node from left hand side, and tail will point to the right node, first right node. Okay, that's clear. Now we'll create a for loop as I mentioned, जैसे मैंने कहा था, to fill in the data and making connections. Okay, so what we'll do now, we'll take a integer value from the user, input लेंगे, and we'll create a new node. We create a new node with value as data. And what we'll do next, we'll check, basically we'll check, that is, if head equal to null, means our linked list was empty and this new node is the first node of linked list. So whenever we'll get a first node, what we'll put? We'll say that node is called the head node also, and that node is called the tail node. Means the first node from left hand side is also the new node, and the first node from the right hand side is also the tail node. Okay, good to go. And supposingly the head is not null, that means the linked list has some nodes already. It's not empty, maybe one node, two node, or three node, at least one node. So what we'll do, we'll say tail.next equal to new. That is, we'll keep on adding new nodes on the right hand side. Okay, on the back side, not on the front side, rear side. So we'll say tail.next equal to new node. So this is step one. And then what we'll say that tail is also the new node now. So step two. So we have modified our tail. Okay. So first we pointed tail dot next. That is the next of the tail that was initially null. Now it points to new node. And then we said, okay, now the tail has moved and the new node is the tail node. That's the way you have to make the connections. At the very end, you can also say tail dot next equal to null. Okay, but it's optional because if you are not attaching then this statement, we are not writing. अगर तुम ये नहीं लिखते हो, so what will happen? It's automatically understood by Java that the next pointer is null. Okay. तो अब तक हमने क्या किया? What we did so far is we created a linear singly linked list. Now we asking the user. हम यूजर से पूछ रहे हैं पोजीशन क्या है? What is the position where we have to create a cycle? So this is cycle position, and this could be like anything from 0 to size -1, anything, or we can also say 1 to size, any number. Okay, so in this scenario we are following the syntax 1 to size. So it can be 1, 2, 3, 4, 5, as size was 5 taken in this example. So what we'll do, we'll create a if statement that the position is positive. If the position is positive, then we can create a cycle. If it's negative, then that index cannot be covered in the linked list, right? So what we'll do, we'll create a temporary node as head. So temp points to head, and the cycle node points to null. A count of 1, count equal to 1. Now till when we have to go? We have to check if count is reaching to the position, then that is the place we have to create a cycle. वो जगह है जहाँ पे हमें loop create करना है, ठीक है? So what we'll do, we'll traverse on the linked list from left to right. So temp is pointing to head. So we'll say while temp is not equal to null, that is until we have covered complete linked list from left to right. Okay. Now we'll check if count equal to position. That means this is the position where the cycle node has to be and where we have to create a link from the tail to the cycle. So what we'll do, now we'll assign cycle node to temp. So this is if block, and if that is not the scenario, then we'll do nothing. When we'll reach count equal to position, then we'll do this. And whenever we'll get this scenario, जब हमारे साथ ऐसा हुआ कि temp dot next equal to null है, if temp dot next equal to null, that means this is the place that is the end of the linear linked list from left to right. If there was no cycle, if there was no cycle, so now we know the cycle node position. तो अब हम क्या करेंगे? We'll make temp dot next, which was initially pointing to null. We'll say temp dot next was null previously, but now for making a loop, it should point to the cycle node or position node. Okay, that's clear. So we'll make a break statement. We'll come out of the while loop, and this while loop will work up to temp not equal to null. So we'll have to keep moving temp by 1. So moves one step at a time, and we'll increment count. Okay, good to go. And once everything is done, we have created a linked list, we have assigned a loop also, then we can call our function called hasCycle, and it takes a parameter head. So if it returns true or false, we have to print that. So if this is true, then it will print true, else it's print false. And this is called ternary operator question mark colon. So let's run this once. Now let's give an input 5. Say our nodes are 1, 2, 3, 4, 5, and I want a cycle to be at the third position, that is 3. So it will be like 1, 2, 3, 4, 5, then again 3, 4, 5, and 3, 4, 5, like that. So it was a 2. Okay, that's all for today. Thank you.